Hello everyone, in this video we will learn all about trigonometric identities. To begin with, let's compare and contrast identity and conditional equation. An identity is an equation that is true for all real numbers, while a conditional equation is an equation that is true for at least one real number. An example of an identity is this one. This is a difference of two squares, which is basically the product of the sum and difference of its roots. So meaning here, whatever value we replace x and y with, it will always make this equation true. For example, we will have x as 4 and we will have y as 3. So we will replace x and y with those values and we will end up with this. 16 minus 9 is 7, which is exactly the same with 7 times 1. Again, this is an example of an identity. Another. Number 2 is considered as a trigonometric identity. In this case, our variable here is theta. So meaning, whatever value we replace theta with, it will always make this equation true. Again, example 2 is considered as a trigonometric identity. It involves trigonometric function which is true for all values of the variables. Now, for conditional equation, 5x minus 3 is an example of a conditional equation. Why? Because this equation is true only if the value for x is 2, because that would become 10 minus 3, which is 7. Another example, sine squared theta is equal to cosine squared theta plus 1. This is an example of a conditional equation, because there are only certain values of theta that will make this equation true. Now, let's review the 6 trigonometric functions. So, given this right triangle, this is theta, this is side A, side B, and our hypotenuse C. So, given this, our sine here, or sine theta, would be opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, in which we can derive the secondary trigonometric functions as the reverse of sine is cosecant. So, opposite over hypotenuse, hypotenuse over opposite. For secant, this is hypotenuse over adjacent side. Well, for cotangent, this is adjacent over opposite. Now, considering this trigonometric functions here, we can derive the trigonometric identities. Take note, sine, its inverse is cosecant. For cosine, it's secant, and tangent, it's cotangent. With that, we can identify our reciprocal identities, in which sine theta is just the same as 1 over cosecant theta. So, the same for cosine and for tangent. Another, quotient identities would simply mean tangent is opposite over adjacent, or that's sine theta over cosine theta. Well, for cotangent, it's cosine theta over sine theta. Now, take note, we can use identities to simplify trigonometric expressions. Take note of this. Now, let's have this. So, these are reciprocal identities and these are quotient identities. Now, basic rule in simplifying equations is to rewrite functions in terms of sine and cosine. Now, that's a basic rule in simplifying. So, in this case, we can have tangent as sine over cosine. So, times cosine theta divided by sine theta. In this case, we can cancel cosine and cosine. With that, we can also cancel sine and sine, in which our final answer is 1. Another example, cosine theta divided by cotangent theta. In this case, we will have cosine as is, and cotangent can be replaced with cosine over sine. So, simplifying this, so cosine theta, so reverse this, then multiply. In this case, we can cancel cosine and cosine. So therefore, our final answer is sine theta. Next. Now, another set of trigonometric identities are the Pythagorean identities. Now, going back to this right triangle here, and using the Pythagorean theorem, we can have a squared plus b squared equals c squared. This is the sum of the square of the two legs is equal to the square of the hypotenuse. That's the Pythagorean theorem. Now, given this, we will divide the entire equation by c squared. So, we will end up with this, a over c squared, b over c squared, and we can cancel this and we'll end up with 1. Take note, a over c, that is opposite over hypotenuse, that's basically sine theta. Well, b over c is cosine theta is equal to 1, in which this is the first Pythagorean identity. Next, we can derive second and third Pythagorean identity. How to do it? So, given the first Pythagorean identity, and let's divide this entire equation by cosine squared theta, so we will end up with this. Now, take note, sine over cosine with respect to quotient identity is basically tangent squared theta. And cosine over cosine, you can cancel that and we'll end up with 1. Now, using reciprocal identity, 1 over cosine is basically secant squared. Or, rewrite by commutative property, we will have 1 plus tangent squared theta equals secant squared theta. That is Pythagorean identity number 2. Now, to get the third Pythagorean identity, so still using the first Pythagorean identity, let's divide the entire equation by sine squared. In this case, we will end up with 1. Cosine over sine by reciprocal identity is cotangent, and 1 over sine with respect to reciprocal identity is cosecant. So simplifying, this is Pythagorean identity number 3. So take note, that's how are you going to derive. Now, let's have this one. So these are Pythagorean identities. So let's simplify this applying this one. So again, cosine squared theta plus cosine squared theta tangent squared theta. In this case, cosine theta is common. So let's factor out cosine squared theta. We will end up with 1 plus tangent squared theta. Now take note, 1 plus tangent squared is equal to secant squared theta. Now, using reciprocal identity, secant squared is basically 1 over cosine squared theta. So in this case, we can cancel this and we can cancel this one. So we will end up with 1. Another example. This is 1 plus tangent squared theta divided by 1 plus cotangent squared theta. Now in this case, 1 plus tangent squared theta using pi is secant squared, while 1 plus cotangent squared is cosecant squared theta. Now in this case, using reciprocal identity, secant is 1 over cosine squared theta, while cosecant squared is 1 over sine squared theta. So simplifying this, so reverse the denominator, then multiply. So we will end up with sine squared theta over cosine squared theta. Now take note, by quotient identity, sine over cosine is tangent. So therefore, the simplified value of this is tangent squared theta. Next. Okay, so take note, these are the fundamental trigonometric identities. We have the reciprocal, we have the quotient, and we have the Pythagorean identities. And we also have even-odd identities, or sometimes they are termed as opposite angles identity. So meaning sine negative theta is just the same with negative sine theta. Take note of that. Or that would mean sine negative 30 degrees is just the same with negative sine 30 degrees. That's even-odd identities. Okay, so let's use the different identities in solving for this. First, if sine theta is equivalent to negative 3 over 4 and cosine theta is greater than 0, find cosine theta. So how to solve this one? Now take note, Pythagorean identity, we have this. Sine squared plus cosine squared is 1. Now, cosine squared, transferring sine squared to the other side, we will have this 1. And getting the square root to both sides, we will end up with cosine theta equals square root of 1 minus sine squared theta. So with this, we will use this one. So since our sine is given as negative 3 over 4, we will simply replace that. So 1 minus negative 3 over 4. So since it's squared, so it's raised to the power of 2. So simplifying, we will have 9 over 16. And simplifying further, so 16 minus 9, we will have square root of 7. And square root of 16 is 4. So meaning, if sine theta is negative 3 over 4, cosine theta would be square root of 7 over 4. Another example. If secant theta is equal to 5 over 2 and tangent theta is less than 0, find the values of sine theta and tangent theta. Now take note, secant here is positive and tangent here is negative. So therefore, this is located in the fourth quadrant. Next, secant is 5 over 2. So therefore, reversing that, we will have cosine as 2 over 5. Now take note, to solve for sine, we will use this. From the Pythagorean identity, we can derive this as sine theta is equal to the square root of 1 minus cosine squared theta. So you might wonder, how come this is negative? This is negative because sine in the fourth quadrant is negative. So substituting this, our cosine is 2 over 5. So simplifying further, this is 4 over 25. Or 25 minus 4, that would become square root of 21. While the square root of 25 is 5. So therefore, if cosine is 2 over 5, sine is negative square root of 21 over 5. Okay, next. What about tangent? Now take note, tangent using quotient identity is sine over cosine. So we will simply replace this with this one and cosine as 2 over 5. So simplifying, reverse the denominator and multiply. You can cancel 5 and 5, so therefore our tangent is negative square root of 21 over 2. So, take note, if cosine is 2, 5, sine is negative square root of 21 over 5, and tangent is negative square root of 21 over 2, these points here are located in the fourth quadrant. Now, to get the secondary functions to this, we will simply reverse. For cosine, the reverse is this one, secant. For sine cosecant, simply reverse this. For cotangent, also reverse this one, then rationalize. Next. Okay, now take note, it's very important to memorize the different identities. Now, to easily do that, you can make use of the magic hexagon, or this is considered as a tangent sine cosine hexagon. So, to help you remember, the co-functions are located at the right. So, sine, cosine. For tangent, cotangent. And secant, cosecant. To get the reciprocal identities, simply pass through 1. So, meaning sine is 1 over cosecant. Cosine is 1 over secant. Tangent is 1 over cotangent. Or you can also reverse that as cotangent is equal to 1 over tan, cosecant is 1 over sine, and so on. So there are actually other reciprocal identities that you can derive. That's for reciprocal identities. Okay, next. Now for quotient identities, we can simply move clockwise. So for example, tangent is sine divided by cosine. For cotangent, simply reverse that. So for cotangent is cosine divided by sine. So going around the hexagon will give you quotient identities. Okay, so that's why we can have sine is also cosine divided by cotangent. Cosine is cotangent divided by cosecant, and so on. So these are the complete set of QIs. So counterclockwise, so you will get this. Okay, next. For Pythagorean identities, you can identify using the magic hexagon by going clockwise around any of the 3 triangles. So take note, the first triangle is here, this is second, and this is third. So meaning sine squared plus cosine squared equals 1. Then next, 1 plus tangent squared equals secant squared, or that could be tangent plus 1 equals secant squared. This one is 1 plus cotangent squared equals cosecant squared. So that is Pythagorean identities. Although if you move counterclockwise, you can also get the other set of Pythagorean identities. So if the movement here is clockwise, counterclockwise would be 1 minus cosine squared equals sine squared. Secant squared minus 1 equals tangent squared. Cosecant squared minus cotangent squared is equal to 1. So that's it. And the other one is the product identities. So meaning, how to do this? A function between any two functions is equal to them multiplied together. So for example, this one, tangent times cosine is equal to sine. Secant times sine is equal to tangent. So cosine times cosecant is equal to cotangent. That's an example of product identities. Although you can also multiply functions that are opposite with each other. So for example, tangent times cotangent equals 1. Sine times cosecant is equal to cosecant. So remember, they are reciprocal functions. That's why it will always end up with 1. Now, an example proving this would be tangent 30 times cosine 30 is equal to sine 30. So tangent 30 is square root of 3 over 3. This is square root of 3 over 2, and this is 1/2. So with this, we'll have 3 over 6, and simplifying, 1/2 equals 1/2. Okay, another. This one is the co-function identities. So sine, cosine, tangent, cotangent, and secant is cosecant. So meaning sine x is equal to cosine 90 minus x. So how come it's 90? It's because in the right triangle, one angle is 90 degrees. So the two acute angles should always end up with 90. So meaning sine 30, it is just the same with cosine 60. Because sine and cosine are co-functions, 30 plus 60 will end up with 90 degrees. So we can always counter-check this. So sine 30 is 1/2 and cosine 60 is also 1/2. Another, tangent 20 is equivalent to cotangent 70 degrees. Tangent, cotangent. 20 plus 70 is 90 degrees, in which if you will get its value, you will end up with this one. Okay, now let's have proving identities. Now these are the basic rules in proving identities. So Number one, it's important to memorize the fundamental identities. So you can transform the left and the right equation, or you just transform one equation to be the same in the other side. So do not cross multiply and substitute in terms of sine and cosine. No, it's basic. An example. Sine theta times cotangent theta times secant theta is equal to 1. So let's prove this one. So sine as is for cotangent, we can replace this with cosine over sine. Second, reciprocal identity is 1 over cosine. In this case, we cancel sine and sine, cosine and cosine, so we'll end up with 1. Another example. So cosine squared times 1 minus cosine squared is equal to 1. For cosecant squared, we can rewrite as 1 over sine squared theta. This is reciprocal identity. This one, by Pythagorean identity, we will have sine squared theta. So we can cancel this, so we will end up with 1. Another example. Sine theta, secant theta is equal to tangent theta. So sine theta, this is as is. For secant, reciprocal identity is 1 over cosine. For tangent, this is sine over cosine. So simplifying, it's exactly the same. One last. Sine theta divided by cosine theta, tangent theta is equal to 1. For sine and cosine, we will have that as is. For tangent, using quotient identity is sine over cosine. In this case, we cancel cosine and cosine. We cancel sine and sine, so therefore we will end up with 1. Okay, another example. Okay, secant theta minus cosine theta is equal to sine theta tangent theta. Now for secant, for reciprocal identity is 1 over cosine theta. This is as is. Sine theta as is. So for tangent, quotient identity is sine over cosine. Now simplifying this, we will have 1 minus cosine squared, and sine times sine is sine squared theta. Now take note, 1 minus cosine squared using Pythagorean identity is basically sine squared theta over cosine, which is exactly the same with the right side. Now, in proving identities, there are different ways in doing it. So this is one way. So I will show you how to do it using another way. So again, using the same equation, we will have this one. So in this case, we only transform the left side of the equation and have the right side as is. So simplifying, so the same thing here. So we will end up with sine squared theta cosine theta. Now in this case, you factor out sine. So this is sine over cosine, in which by quotient identity, sine over cosine is tangent theta, which is exactly the same with the other side. Now take note, in the first way of proving, we transformed both sides of the equation into the same new form, while in example number 2, we transformed into exactly the same form as the other side. So both of these are correct. Now, let's have the other trigonometric identities. So the first one, we have the angle sum and difference identities, or others would have this as sine and cosine identities. So cosine A plus B is the same as cosine A cosine B minus sine A sine B, and so on. No? So minus, we will have this. For sine, take note of its corresponding identities. So cosine, sine, and for tangent. So these are, or sometimes they are termed as the general addition identities. Okay, another set is the double angle identities. So twice cosine 2 theta, we have sine 2 theta and tangent 2 theta. So take note of this. No? Okay, so Another is we have the half angle identities. So an angle divided by 2. So take note of this. Find the exact value of cosine 105 degrees. Now take note, 105 is not a special angle. So it's very important to rewrite this in terms of the special angles. So with this, we can have this as cosine 105 is equal to cosine 60 plus 45 degrees. 60 plus 45 will end up with 105 degrees. So with this, we can make use of cosine addition identity. So with this, substituting here in this equation, we will have cosine 60, cosine 45 minus sine 60, sine 45. So with this, we can replace with this one. So this is 1/2 square root of 2 over 2 minus this is square root of 3 over 2 and square root of 2 over 2. So simplifying, we will have this one. Then combining these terms, cosine 105 then is square root of 2 minus square root of 6 over 4. Okay, another example. In this case, find the exact value of tangent 120. So take note, 120 is not a special angle. So with this, we can rewrite this as tangent 60 plus 60, in which we can use here the general addition identity for tangent. So with this, we replace. So this is 60. So tangent 60 is square root of 3. So combining like terms, this is 2 square root of 3. So square root of 3 times square root of 3 is 3. So 1 minus 3 is negative 2. So simplifying, tangent 120 degrees is negative square root of 3. That's how we're going to do it. Now, another way of solving for tangent 120 is to make use of the double angles. It's because you double 60, we will end up with 120 degrees. So with this, 2 times 60 and replaced here. So simplifying. So again, tangent 60 is square root of 3. So tangent squared 60, so that would be square root of 3 squared. In which square root of 3 squared, you cancel this, we will end up with 1 minus 3. So simplifying further, still we end up with negative square root of 3. So that's how are you going to do it. Another. Find the exact value of sine 15 degrees. So take note, 15 degrees is not special. So you have to rewrite this in terms of special angles. So with that, we can have sine 45 degrees minus 30. Or it could be 60 minus 45. That's the same thing. So with this, we can use general addition identity for sine. So given this, let's substitute. So sine 45, cosine 30. This is cosine 45 and sine 30. Although you can interchange. No, that's commutative property. So with this, square root of 2, square root of 3 over 2, square root of 2 over 2, and 1/2. So simplifying and combining like terms, sine 15 degrees is square root of 6 minus square root of 2 over 4. Okay. Now, another way of doing this is also making use of half angle identities. It's because 15 is basically half of 30 degrees. So that's sine 30 over 2. So simplifying. So cosine 30 is square root of 3 over 2, and simplifying, we will have this and combining like terms. So getting the reciprocal and simplifying, this would become the square root of 2 minus square root of 3 over 2, in which the value of this is exactly the same with this one. Okay, next. Inverse trigonometric functions. So when you say inverse functions, it's denoted by the symbol y is equal to sine to the negative 1 of x, or y is arcsine of x. So when you say sine to the power of negative 1, it's just the same as arcsine. So meaning it means you're referring to inverse functions. So Let's have an example. Find the exact value of each expression. So sine, inverse sine of 1/2. So it simply means arc sine 1/2. So what does it imply? So meaning sine theta is equal to 1/2. So meaning you had to find an angle measures so that when you get the value for sine, the result is 1/2. So with that, so theta here is 30 degrees. You can always counter check. So sine 30, it will give you 1/2. So again, arc sine 1/2 is 30 degrees. Another. Arc cosine is 0. So this would mean cosine theta is 0. So you have to find an angle in which when you get cosine with that value will result to 0. In this case, this is 90 degrees. So counter checking, cosine 90 is indeed 0. Now, how to easily do this? So given this, you can make use of your calculators. So using the calculators, you simply have this process. Press the value, press equal sign, then press shift key, then press the function and press equals. So for example, referring to the first example, so the value here is 1/2, so equals, then shift sine equals, it will give you 30 degrees. Okay, another example. So arc tan is square root of 3. So meaning tangent theta is square root of 3. So this would be square root of 3 equals shift tan equals, and it will give you 60 degrees. So checking this, tangent 60 will indeed give you square root of 3. Okay, another. Okay, this one is secant, arc secant 2 square root of 3 over 3. So this would mean secant theta should give you 2 square root of 3 over 3. With this, you can get 30 degrees. So counter checking this, secant 30 degrees will indeed give you 2 square root of 3 over 3. Now take note, secant is a secondary functions. With this, you cannot find this in your calculators. So how to solve this using the calculators? So press the value, press equals, you press the inverse key, you press equals, then press shift key, then press the reciprocal function. So in this case, the reciprocal function of secant is cosine, then press equals, then press degree key. Okay, so for example, this one, it's 2 square root of 3 over 3 equals, the inverse key is x to the negative 1, or to some calculators, it's 1 over x. Then equals, then shift, cosine, because that's the inverse of secant, then equals. Then you can press the degree key. So it will give you 30 degrees. So for example, this is arc cot 2.75. So with this, cotangent theta is 2.75. So 2.75 equals inverse equals shift. The inverse of cot is tangent equals. So it will give you 19 degrees, 58 minutes, and 59.18 seconds. So counter checking this one, it will give you 2.75. Now, you might wonder how to get cotangent using the calculators. So to do that, use this. So the inverse of cot is tangent. So that would be tangent. This is 19 degree key, 58 degree key, 59.18 degree key equals, then you press inverse and equals, it will give you around 2.75. That's how are you going to do it. Okay, now how to solve trigonometric equations. So sine theta minus square root of 3 equals over 2 equals 0. So simply transfer this value to the other side, we will end up with this. So theta here is arc sine square root of 3 over 2. So therefore your theta is 60 degrees. Another example. 3 tangent theta minus square root of 3. So transfer to the other side. We'll have this. Dividing the entire equation by 3, we will end up with this. So this is arctan, square root of 3 over 3, or that would be 30 degrees. Another example. This is cosine theta equals 1.75. In this case, this is actually undefined. Okay, my question is, how come this is undefined? It's because the values for sine and cosine should always be lesser than 1. And values for cosecant and secant is always greater than 1. Take note of that. Okay, so cosecant theta is 4.5. So that would be arc cosecant 4.5. So the result here is 12 degrees, 50 minutes, and 22.52 seconds. Okay, so let's have a sample situational problems involving general addition formula. So a student is viewing a painting in a museum. Standing 6 feet from the painting, the eye level of the student is 5 feet above the ground, and if the painting is 10 feet tall and its base is 4 feet above the ground, find the viewing angle subtended by the painting at the eyes of the student. So take note, illustrating this, we will end up with this. Now, or it's simply the same as this one. This is 4 feet above, so plus 10, that's the height of the painting. The student is 6 feet away, so 5 feet above the ground is the eye level of the student. So take note of this. So let theta, so this angle here will be the viewing angle. And theta is the same as angle alpha plus angle beta, as shown here. So tangent alpha, so this angle here, so tangent is opposite over adjacent, so opposite is 1 and the adjacent side is 6. And tangent beta, so this angle, the opposite is 9 and the adjacent is 6. So with this one, using the tangent sum identity or the tangent addition identity, we will have tangent theta is equal to tangent alpha plus beta. So given this, let's substitute. So tangent alpha is 1 over 6, tangent beta is 9 over 6 over 1 minus tangent alpha is 1 over 6 and this one is 9 over 6. So simplifying, we will have 20 over 9, or that would be inverse tan of 20 over 9, which is approximately 65.8 degrees. So therefore, the viewing angle is 65.8 degrees. So the measure of the angle here, which is basically the viewing angle that will cover from the bottom going to the top, is approximately 65.8 degrees. Okay, so that would be all about trigonometric identities. Thank you.